Alright, if you watch my YouTube channel, you know that I enjoy making grips for the 1911 pistol. It's an admittedly odd hobby for a guy that doesn't actually own a 1911. Now, occasionally I'll get a request to inlay an object into a set of grips, usually some sort of military or law enforcement insignia. They look sharp, but I'm always afraid that the objects will detach with prolonged use. Plus, these objects upset the overall contour of the grips. I was able to mitigate these challenges a bit by engraving representations of these emblems. This approach works well, but doesn't produce quite the same effect. Hence the purpose of this video. I want to try something a bit different. Inlaying an object and then covering it with epoxy to make sure that the object can't ever detach from the grips. Emblems and insignia cost money, so to prove the idea, I'm just going to use some soda can tabs. Time to run a little computer simulation to see how deep I need to cut my stock. I want the pocket to be as shallow as possible, but still make sure that the object is completely submerged in epoxy. These magenta lines represent cross sections of the grip and will give me a good gauge for my depth limit. I'll switch my view to the XZ plane and then move the soda can tab up about 110 thousandths of an inch. It looks pretty good. Near the surface, but still well clear of any magenta lines. That computer simulation probably wasn't necessary for my current experiment. A soda can tab will obviously fit inside of a 1911 grip with plenty of room to spare. However, it's going to pay off if I ever embed larger objects, especially if those objects happen to be owned by the customer already. I'd hate to ruin a project and tell the customer that I broke their property because I didn't do my math correctly up front. Anyhow, with that behind me, I can start the fun part, making sawdust. I'll need to prepare several sets of blanks because, let's face it, these things never go right the first time. I'll speed through the process of milling up my blanks. It's a pretty basic process. All that I'm doing is squaring up two sides of a large piece of stock and then turning it into many smaller pieces. I've covered the specifics of my process in other YouTube videos if you want more details. Now you may have noticed that I'm using some top quality wood on this experiment. That's because I want to see how this specific species, which is cocobolo, reacts with the epoxy that I'm going to use. Cocobolo is a popular material for pistol grips, but it's very oily. I want to know if that oil is going to leach into the resin that I'm about to use. I think 2 sets of blanks will be enough to get me started. You can see that they're all milled up, and now I just need to attach them to my grip making fixture. Alright, perfect. Let's head back to my CAM software. It's time to generate the G-code, or machine movements, that's going to make the pockets for my soda can tabs. Remember that 110 thou limit from earlier? This is where I'm going to utilize that value. Normally I like to zero my Z-axis at the top of my stock, but I make an exception for pistol grips because stock thickness varies from set to set, so I program using the bottom of my stock as 0Z. Anyhow, a bunch of other variables combine to make a set of toolpaths which looks something like this. Now it's time to make some more sawdust. Now this is where things actually start to get interesting, but unfortunately the footage is going to be fairly lackluster. I am cutting the pockets for these soda can tabs, but I do have the dust collection skirt installed on my router, so there's not much to see. That said, let's just fast forward to the end of the clip and you can see the completed pockets. They turned out quite well, I have to say. Should be a nice tight fit around the tab. And here comes the moment of truth. I was going for a nice tight press fit. And when I say press fit, I mean press with my finger, not with an actual machinist press. That looks pretty good, so we can move on to the next phase. I'll be using 2 different resins with this experiment. The first is this polyester casting resin. I've worked with it before, it dries clear, but I also know that it smells terrible and I have to work with it outside. The second is this 5-minute clear epoxy made by Loctite, and it should work because it's got a picture of a glass table on the package. Mixing and pouring the 2 different resins was actually very straightforward. I just went outside, put on a full face respirator, and followed the manufacturer's instructions. You will notice that I'm not wearing gloves during this shot, and that's just me being stupid. I really wish I had worn gloves. I had gloves available. I'm not sure why I didn't put them on, and I definitely don't plan on repeating that mistake if I work with this stuff again in the future. Anyhow, once everything was poured, I let it set for a couple of days and then moved on and machined them just like any other set of grips I'd make. Let's show some of the results of the epoxy pour. Start with the Loctite epoxy product, which supposedly dried clear. Epic fail. Maybe it dries clear in very, very small amounts, but you can see all the bubbles right there. Off camera, I did pour another set with that stuff and I put it in a vacuum chamber. And you can see that did a little bit to reduce the amount of bubbles. I'll machine this one. And here's an example of what the casting resin looked like. Much more optically clear, but still, I don't think it's quite the product that I want. I'm going to cover the remaining machining steps very briefly because I've already covered this in another YouTube video. This is the radius, the one up the top of the grip. I lost the footage of me cutting the outside profile, but that's alright. Now I'm cutting the curvature, and that white dust you see, that's the resin actually being machined. And at this point, it's looking an awful lot like a pistol grip. It's just one more machining operation to go. And that's to cut the bevel down by the mag well. You've been a good sport about watching everything through the dust skirt, so I left it off for this clip. Let's wrap up this video with the results of my little experiment. Regretfully, my little pocket camcorder is the best video recording equipment I have, and it really doesn't do these grips justice. They look quite sharp in real life. I would say that neither one of these resins is exactly what I wanted. We'll start with the one that looks a little better on camera anyway, and that's the casting resin. It looks nice, I like how it's optically clear, but it shrunk a little bit, and if I run my fingernail across that casting, I can really feel where the resin leaves off and the cocobolo starts, and that's not acceptable. Moving on to the Loctite product, that did a much better job filling the entire void, not shrinking. I'm sure it's probably much, much stronger than the casting resin. But you can see it's full of all sorts of little bubbles and debris that I sucked out of the grip when I put it in the vacuum fixture. So vacuum fixture, probably not the way to go in the future. And the Loctite product, at least that particular one isn't quite what I'm after either. Now I do have more stuff on order. That's going to become part 2 of this series. I'm not giving up on this dream just yet. Now I made this video to generate discussion, and if you can think of something that I might have forgotten or could have tried differently, please write in and let me know. Hope to hear from you, and thanks very much for watching.